Hello, OSHWA Nation. Welcome back to another episode of Show and Tell Monthly. We're in the November 2025 Show and Tell. So this is the one that kind of goes over some of the stuff that we got to see get certified during October, Open Hardware Month, which is always a really fun time for us. We had a really great Open Hardware Month this month. We got to do a lot of really fun stuff. We had a great time doing the 12-hour live stream, as well as the regular monthly live stream. It's always really fun just to see what folks are making and getting to hear about their different projects. So that's kind of why we do this whole thing. It's always just like really cool to see what people are up to. As far as general OSHWA updates, we are getting close to the end of the year already. Surprisingly, how does that happen? I don't know. Time marches forward, and I am merely a guest in the time. But we are hitting the end of the year, which means we always like to really reflect back on some of the really cool stuff we've done this year. If you are not yet subscribed to the OSHWA newsletter, that could be a good thing to do. And we are now actively seeking proposals for the 2026 Open Hardware Summit, which will be taking place in Berlin, Germany at TU Berlin on May 23rd and 24th. So if you have workshops, talks, exhibitions, art, performances, any of this stuff, we're happy to take all of it. We love to see what folks are doing, and we love to see the very different ways that open source is being explored. So if you are looking to potentially share your work with the summit and everyone who attends, you can go to 2026.oshwa.org and find all of the information for the call for proposals, as well as the Summit Fellowship is also now seeking applicants. So this is a fellowship that runs for the months leading up from January to May, leading up to the event, where we do our best to provide mentorship opportunities for folks who are looking to get involved with open source, or who have already been working in open source but want to expand their knowledge of what it could be. So it's a really great opportunity. And then on top of that, we also provide a travel stipend to help get you to the summit. So two really rad things to apply for. We try and keep it relatively simple, so it's not too complicated of an application process, but we would love to have you there and get to hear about your work at the summit or in other methods. And yeah, we're really looking forward to the summit this year. It's going to be a really good year, or well, next year. It was really good this year, and it's going to be really good next year. And time again keeps marching forward. And then for today, we've got 3 new incredible open source hardware creators who've done some really cool stuff that we're really excited to highlight. So let's just get into it. Our first guest of the day is Mike O'Leary. Hey, Mike, how's it going? Oh, I can't hear you.
Yeah,
there we
that's
go.
Shocker. I know why.
The computer, we should have never taught rocks to think. We shouldn't have done this. Computers are weird. There's too many buttons. Welcome. How are you doing today?
Thank you. I'm all right. It's the struggle is real, Sid. It's
So you worked on the universal aircrete mixer.
Yes, I did. And just so first off, I'll just ask how long do I have? How long?
You've got about 15 minutes. Yeah. Sorry.
15 minutes. Okay. So I'm just gonna immediately share my screen here and get into it, if it's okay with you.
Yes, of course.
Okay, I'm gonna go share screen here, and just because this is how we usually do this, right? Share the whole screen. So, so I've developed, and you might say that I've invented a machine. Can you see my screen?
Yep.
Okay,
infinitely.
Good. So I'll just go to right here. This is aircrete, and this is a person who's mixing aircrete. So this is a Portland cement slurry and water, and they're going to add some stable foam to it, which is just soap foam. So now you have Portland cement slurry, which is a binder, and then you have the soap foam, which injects all these microscopic bubbles into it. And so you end up with what's basically a structural insulation product called aircrete. So let's see here. I'm going to get back to you and that. So that's aircrete. And so basically I'm still sharing my screen, aren't I? I lived in a house made out of this stuff. And so this is where my story starts and why I'm doing this. So we were doing a bathroom addition on my aircrete house. Can you see this, Sid? Sid?
Yep.
Okay, good. So I lived in Asia for 20 years. I'm a sailor. I worked on super tankers. And so we built this nice aircrete house. You make it with blocks. The aircrete blocks they're not very dense. It's half as dense as water. So it's a perfect combination of insulation and structural strength. So while I was doing this bathroom addition, I realized that you could make a house with this stuff. You didn't have to buy the blocks, you could make it. And so here's a guy that's making aircrete. So there's different ways you make it. You can either put it in an oven, which is an autoclave, or you can just mix it up in a machine and let it air cure, which is what he did right here. But he had to mix his bags one at a time with like a hand drill. So why don't I go? I've got another picture of the guy with the hand drill right here. This is a guy mixing up aircrete in a bucket. And this is almost like, for residential aircrete production, this is almost like the state of the art, believe it or not. But so here's the video. I'll share the video that sort of put me on this journey, and then we'll get to my machine. So it's these guys in the desert, and they haven't really been given good equipment, and they're like mixing these ingredients by hand. So I'm not going to burn up all my time here, I promise. So these guys make the stable foam, and they mix up their aircrete in a 55-gallon drum with all kinds of extra, like, I don't know, they put handfuls of stuff in here. But they end up with these gorgeous sugar cube aircrete blocks that they've made for next to nothing. And then over here, you can see the mansions they're building with them. So my idea with my machine is that you don't have to do that. You don't have to use this hand drill. Now they do. There is lots of really good high rate production equipment for aircrete. If you wanted to use a machine like this, costs $200,000, but you could build a really good aircrete home in about 2 hours. Don't ask me why they don't do it. It's like, it is literally like the best house. So, are you still there, Sid?
Sure am.
Okay, good. Do you have any questions?
So far, no, I'm following.
Okay, good. But so you're picking up on aircrete. So this is non-autoclaved aerated concrete. So you don't have much sand, you don't have any gravel, and you've got all this soap foam. So you've lowered the density, and you can get it down to a 0.2 relative to water, a 0.15. You can get it very, very light. And so it's a really good insulator, and it's fireproof. It's again, don't ask me why this isn't more popular, but there is I'll put it up here. So this guy's had this stuff since 1983. I've talked to him, and so he put aircrete insulation in half of this structure. And so half of it just pretty much burnt to a crisp, and then the side of the aircrete, it didn't even catch on fire at all. And the inside of the house stayed like below 100 degrees. So your pictures on your walls would have been okay. It's been around since 1983. So let's get to the machine. So that's kind of like the why. And so I wanted to I haven't explained myself very well because I'm terrible at this. But in a childish way, I wanted to disrupt the residential building industry worldwide with my machine.
Someone's got to do it.
With my machine. Well, I got bad news. I don't think it's going to be me. I'm not going real great, Sid. But here, okay. So I should have some. I'm awful with this mouse. Okay, so I've got a picture of the machine, and I should have the pumping direction. So what I did was I developed a machine that It's portable. You can take it apart and get it in and out of the bed of a pickup truck just with human power. And then you can still see this, right, Sid?
Yep.
Okay, cool. So what you're looking at here is you've got a mixing vessel. This is the side view of a mixing vessel of my universal aircrete mixer. This is the version 2. And so what it has is it's got this is where the aircrete gets blended, and then this is a recirculation pump, and then also a transfer pump. And my big breakthroughs with this machine, there's 2 of them. There's 3 of them, actually. The first one is the price. I'm thinking that our bill of materials is going to be much less than $5,000, and these machines cost like $100,000, $50,000. So having a BOM that's low is huge. But also with it being portable, that's big because trailering isn't big in the developing world, and it always costs money. And then also, I saved a bunch of money with this little recirculating pump down here on the bottom. All it is just it's a post hole driller bit. I'll show you what it is. So I made here's my first prototype. So there's a pump in the middle of this tank right here, and this would be called a positive displacement pump. And all it is it's a post hole digger inside of a really strong piece of PVC, which is called a pump can. And so it's just like a 1,000-year-old technology to pump and mix this water. And so that's what I was able to do with both versions, where take advantage of portability, and then also take advantage of what is a very cheap way to pump this material.
Mm-hmm.
So it's recirculating here. So, okay, I'm gonna stop sharing my screen. So, geez, are you still there?
Sure am.
Amazing. I managed to do this. Okay. I still am sharing my screen. How much time do we have left?
Nope, your screen is no longer on, and we have about 8 minutes.
Okay. Oh, cool. Okay, so we've had an overview of aircrete a little bit, right?
Mm-hmm. Yes.
So there's some key points here. It's been around for about 80 years. It's used widely in commercial and industrial construction worldwide, but like only for that.
Mm-hmm.
They never really brought it across the street to residential housing, at least in North America. It's like number 1 in Europe. Yeah. It's huge in Asia. They don't bother building with cinder blocks anymore in Asia, really. They use aircrete blocks, which is good. But see, I just said, oh, but they do use it in residential. So I mean, they kind of do. It's. I've watched this product developed in Asia, and it's okay, but they should have done more of it here in the United States, because stick frame houses are objectively terrible. And then also, we should have pushed past using these blocks that are really inefficient to make and transport, and we should have been site casting all of this stuff. Because that's what we can do. That's what those kids were doing in that drum. They're site casting it. And so there's a huge environmental benefit to site casting a building material. Now, I don't want to leave the studio here. I must leave. It's fine. It says I'm sharing.
No, you're good. No one can see it.
I'm not sharing?
No.
I'm not sharing?
No.
Okay, well, no, I want to share though.
Oh, you want to share again? Yeah, I can put it back on stage, yeah.
Yeah, oh, okay, my bad. Okay, so, and I actually never sent you my, my GoFundMe link, but that's okay. What am I supposed to be talking about here? Okay, I am sharing again, and I'm going to get back to the open source aircrete. So really, it was the cost of the equipment that held this back. That's what I wanted to say. So if you wanted to build with site cast aircrete in the United States, and you're a contractor, you're going to buy this $200,000 piece of equipment, and that's going to be, you know, your job. You're going to lay that stuff out. You're not going to be like a small contractor who can use this machine like once or twice. Maybe you rent it at Home Depot. You know what I mean?
Yeah.
So, that's where I went with this, and I've had struggles. You know, how would you say, like, are most of the people that do their certifications here, are they involved in an organization?
It really varies. Some folks are heavily involved with different organizations, and so a lot of people are just working independently on a project that they're really passionate about.
That's the thing. Yeah, I've been working on this. I started last July, when we were trying to buy the right blocks to build my bathroom in Asia, and we couldn't find them. And I said, well, and then it was like, oh, you know, maybe we could make our own. And so the other thing, and this is, I should have had some stuff written down to say here, huh? So aircrete works here. I'm gonna grab the GoFundMe here. Aircrete works really well with all of the other. It's complementary with all of the other alternative building methods. So you've probably heard about some of them. We'll go through them. There's like earth bag, there's straw bale, there's tire homes, things like that, right? And so, in my humble view, those technologies are fantastic, but there's huge drawbacks to them, and usually it's the insulation. So if you think about an earth bag home, I don't know if you're familiar with this. You take dirt and you might take some binder, and then you're going to put it in a bag, I guess. I don't know much about it, but you're going to end up with something that has too much thermal mass. So it'll be too cold in the winter. It'll be too hot in the summer. My dad lives in an adobe house, and it's the same way. There's just too much mass. So if you can get something lighter like aircrete in there as insulation, that's what you want. Now you've got a perfect home. It's going to be cheap. It's going to be, you know, thermally efficient, green, all that stuff. So this is, and I'm just all. This is how we should rebuild Gaza.
Yeah, I mean,
it
seems like
there's
a lot of applications.
I'll explain. It's a monolithic pour. It's a monolithic pour concrete product. So usually you can't do that because there's too much thermal mass. Regular concrete is a 2.4. It's 2.4 times as dense as water. It's extremely dense. It's okay for like shear columns and like your little strip footings and stuff, but there's a reason why they only use regular concrete for some stuff in a home. You can still do that with aircrete. You put the shear columns, you know, full strength reinforced concrete shear columns, strip footers, all that stuff. But then you get the truck to come in, like in that picture, and it could, I'm not exaggerating, it could be like 2 or 3 hours that they could have these forms set up, and you just blow the aircrete in, and it's this would be a disruptive building technology that they haven't, industry experts haven't spent any time looking at this.
Yeah. I mean, it seems like there's like a lot of really interesting use cases here, and like there's a lot of folks who have done different versions of, and like we're in the process of working on certifying different ways of doing an open source house, but usually using kind of traditional building methods or building materials. So something like this could be a really great way to really expand the access and make it that, I mean, I feel like overall the cost of building with aircrete is probably a lot lower than, you know, buying wood and cinder blocks and things that like we got used to using these things that are really expensive. Really expensive.
The pictures of that home that I showed you, before I painted inside that place, I pressure washed it.
Yeah.
I pressure washed it. You know, like that. And And like you said, cheap. Sure, it's cheap. The walls are just made out of that aircrete with a tiny little coating of mortar on each side. Like that's it. No 2x4s. The service channels are cut out. It's like really easy. You can cut out with hand tools to get the. I mean, it's brilliant to build with, and they've. Oh boy, they missed out on a bunch of stuff, and it's tough because I'm not qualified really to be doing the stuff I'm doing, but I have to be on the phone with these, with these academics and these industry people, and it's tough to get them to even consider this stuff. But then, I also have to understand my part in it, and then I don't understand what they're doing, and it's the struggle is real.
It's always a mission. I think that's like a really fun thing that we see a lot with open source projects is like people get really passionate about something that might be kind of niche, but it ends up applying to a lot of people, and then you do have to like figure out moving through these spaces that have had kind of an industry standard, and maybe the industry standard is oftentimes not the best way we could be doing things now.
Yeah, definitely, and I think it seems like, especially in certain cultures, they've really hung on to old, bad building methods.
Yeah. This is actually something that came up a few years back. I was speaking with some folks in Panama, and one of the ways that they develop homes in Panama is that they will have them. The first floor is like what you would traditionally consider the first floor is actually, it's like the house is on risers so that airflow can happen underneath to keep things cooler overall, because it is a very hot space, a lot of humidity and everything. So that way there's still like natural cooling techniques happening throughout the home. And then as we've seen climate change affect new areas and seen things shift in places in the States and Canada, some folks have wanted to kind of adopt these building methods, but no one wants to do them in North America because they're not familiar with them and they're kind of scared of them. When it's like, well, this would actually be a really effective way to like start working with our spaces and making it more accessible and making it easier for folks to, keep cool as the planet keeps getting hotter.
100%. 100%. And I think, like you said, people want to do alternative building. And one thing that somebody told me once about the construction industry that stuck with me, and I think about it a lot, it's a very conservative industry. So, there's that. And it's for a reason. It's because, people want to be safe in the houses that they live in and everything. But getting just the inertia, I think there's going to be a lot of inertia there with certain cultures, but then other cultures, they just snapped it right up, and a lot of that has to do with off code building, which I did some very humble non-technical research, and it identified a bunch of different ways that aircrete could be used for off code building. One of them is like refugee camps and emergency shelters. Sure, you could get in there and build some nice structures. I know that's not everybody's goal. But so it's for my work to move forward. I think I would need a pilot program, and then documentation of the right kind of structures. Because even though they do exist, there's like, I know one producer who did it like on the up and up. He used something called an ICF. It's an insulated concrete form, and then he just put high grade aircrete into it, and it was like he ended up with an R50 wall. And this is like a licensed producer. This is a guy who pours aircrete for highway roadbeds. You know what I mean? So it's like good stuff. So it's like we could do it, but there has to be a will for it, and then there has to be pilot programs and documentation, and if I'm the only one working on it, I need help. So thanks for letting me do this. I really appreciate it.
Yeah, we really like to highlight just like what folks are working on. I think there's definitely a lot of like really great ways that people can get involved with this project and find more ways to develop it?
Well, so the whole open source thing, I just knew, like, when I saw the value prop, I didn't talk about the value proposition of aircrete. Like you said, oh, I think it's cheap. It is. With 500 bags of Portland cement, you can basically build every part of a 1,000 square foot home. Now, 5,000 bags of Portland cement here in the U.S. is $25 a bag, so it's $12,500. It's about $6 a bag in the developing world, depending on where you are, right? So 500 times 6 is $3,000. So that was my thing when I was in Asia, and I said, oh my God, if I had a mixer, I could build a house for $3,000. And that was my first idea. I was going to build a demo house in our driveway in Asia. Everybody hated that idea, and it was childish, and it probably wouldn't have worked. but it'll show you, and I was going to slap a big yellow price tag on it, $3,000. That's how much a motorbike costs in Asia. So it is really, really cheap. And it would have been such a great house. Monolithic pour cellular concrete. It's like the walls would have been like R50. Walls would have been a foot thick. So that's what the value proposition is. It's very. I mean, if you wanted to put an addition on your house, or if you wanted to spruce up the insulation somewhere, you had a shed, something like that, this should be an option for you.
Yeah.
And it shouldn't be mixing it in a garbage can.
Yeah.
You should be able to go and rent a mixer at Home Depot or something, or buy one. I mean, it shouldn't be prohibitive. But it doesn't make any sense to me that this equipment doesn't exist.
But it will.
Yes, it will.
Awesome. Thank you so much for coming on and giving us a bit of a rundown on aircrete and the ways that we could actually utilize it in our systems. It's really neat to think about alternative building methods and the different ways that we could actually be providing houses and housing faster and more efficiently.
Thank you for having me. It is my humble opinion that aircrete is the #1 alternative building material, or building material, period. And I mean, that's fine. You can challenge me on that. And if I say that I need help and all this stuff, I'm already getting it from you guys. Like, the support that I've gotten here is about all of my support. So thank you.
Thank you. And we'll talk to you soon, Mike.
Yeah.
Okay, pretty cool project, right? Like the open source ecology team has been working hard on the open source house project, and I think that this utilizing more materials and cheaper materials and materials that are easier to access is always such a great way to kind of eliminate some of the struggles in all projects, but especially open source projects. We often run into issues of access and what people can and can't get where they are. So something like aircrete is like, that's something you can get a lot of places and you can use in a lot of different ways. So I think that that's a pretty cool way to think about ways we can kind of develop what the future could look like together. Next up, we are bringing on Catherine Wakeworth, who's going to talk to us about the Glasgow Interface Explorer. Hey, Catherine, how's it going?
Hello. It's a dark evening in England, so I'm sitting at my desk looking at what I can implement next. So as usual, today I'm going to tell you about the Glasgow Interface Explorer, and I don't have a camera, but I'm going to be sharing my screen pretty much the entire time, so let me try to make that happen. Am I sharing my screen?
You sure are.
All right. So first off, I'm going to talk about what it is, and then about what makes it interesting. Glasgow Interface Explorer is a small device that plugs into USB, and you can think of it as a USB to digital converter. So if you have something that has a digital interface, and it can be as simple as I2C, or it could be as complex as a custom JTAG-based harness or a high-speed microcontroller tracing interface. Yeah, it can probably do that. There are some limitations on how fast it can be, which they'll probably fix in one of the next versions. But the current revision is fast enough for, I would say, 90% of the tasks a professional engineer might encounter that are digital in nature. It's a small device. It's credit card sized. Looks big on the screen. It's much smaller in real life. And at its heart is an FPGA. So what makes it useful is that rather than having, say, a microcontroller inside, which is programmed with a single fixed function algorithm, it has an FPGA inside which doesn't come programmed with anything. And whenever you want to turn it into a particular type of a tool, let's say you want a yard. Well, you invoke a Python program and you can use a command line interface, or you can do it programmatically. You invoke a Python program and the Python program assembles a yard from some logic gates and wires it up so that it appears as a socket-like object. And now you can write some bytes or you can read some bytes. So far, not so interesting, but let's say you want 2 yards. Well, you can have 2 of them. Let's say you want 8 of them. You can still have 8 of them. Let's say you want 16 of them and they all have to be receive only because you run out of pins. Well, you can have that. Let's say you want 2 yards, an SPI, and a JTAG port for debugging, and you want all of them simultaneously, and you want them to work together. Yeah, that also works. And it uses a system called applets, where you can build little pieces of reusable code and you can compose them together. And we provide a pretty rich library of things for many common tasks, mostly around embedded devices. So you have your usual GPIO, UART, SPI, S2C, Quad SPI with a very high performance Quad SPI core. You can usually read a few hundred megabits from an SPI flash in case you're tired of waiting for it to get imaged. And you get parallel flash, you get debuggers for several types of microprocessors, you get radios, you get a bunch of random sensors. Let's say you want to grab some data from a floppy drive where it's decaying, and then you need to restore it by examining the flux level image. Yeah, you can also do that. And all of this is programmable entirely in Python. And for every single of these tasks, you don't need anything but the Glasgow device itself. So it has onboard pull-ups. Every pin can do everything. It's kind of the ultimate multi-tool. And you can do many serious tasks with it. You can do InfoSec research, you can do reverse engineering, retrocomputing, data recovery. But that's not really what makes it interesting, because people have done this before. That's not what makes me continue to maintain this since 2018. I've been doing it, and I've been doing this through the component shortage and through some pretty tough times in my life. The thing that I think it makes it interesting and special is that what it's really made for isn't just serious tasks, but it's made for play. I came up with the idea, well, the name comes from back when FTDI were breaking everybody's USB serial converters. I wanted to make an alternative using an FPGA, and then scope creep happened. This is probably one of the worst examples of scope creep in all history of open source hardware. But what it's really made is for play. So I would sit at my desk and I would look at some device. It could be an SPI flash, or it could be some sort of custom programmable logic. And I would realize that if only I had a special tool or a special PCB with all the right connections, I could program it. I could show something on the display, or I could read out the firmware and so on and so forth. But I couldn't, because I didn't have that. A reasonable person would have probably built a few PCBs. I decided to build one PCB. I sort of succeeded. I wasn't very good at hardware though, and so now it is a collaborative project. I mostly do software and gateware, and we've had a number of other people help with maintenance and build the hardware, both the physical aspects of it and the design aspects. We have the list of names on the website. I don't really want to single anybody out, but I have started this, but I have not made it. Multiple people made it, and all of his contributions are important. So yeah, it's made for play. It's made for you to be able to pick up some device, decide that you want it to be doing something different than it's usually doing, and then in a few minutes or maybe a few hours, if you have to do something completely from scratch, it would be doing that. And this is unusual because to most people, especially a few years ago, but to this day, programming FPGA sounds like a tedious, unwelcome task that is full of rakes you can step on, very painful debugging, awful tooling, and in general, it doesn't sound like fun. It doesn't sound like play. It doesn't really sound like something you would do other than for very large amounts of money. I set out to change that because I want you to be accessible and I want you to be much more fun than usual, which I think the Glasgow Interface Explorer does achieve. And as to demonstrate one of the aspects of accessibility that I worked pretty hard to get is you can run the entire thing in the browser. So if I load this is a browser tab, and I put Python in the browser, and I also put the entire FPGA toolchain in the browser, and I put libUSB in the browser. And now you can open the device. It works through Chrome like nothing. Unfortunately, it's Chrome only. And now let's say you want to, I have it on my desk connected to an Arduino. Let's say you want to see what kind of AVR chip it is. So let's run this. And yeah, that was way too fast. Hold on. Let's do this again more slowly. So what it does is it loads components of the FPGA toolchain one by one, and it compiles everything. This happens completely transparently. As an end user, you can accomplish useful tasks without ever interfacing with a hardware description language at all. So you run it, it does its thing, composing the different prepared components for you together to come on the FPGA, connects it all through libUSB, through a USB to parallel bus adapter, adapter ASIC, the FX2, connects everything together so that you can pretend that you have a TCP socket, the other end of which is on the FPGA, and you can read bytes on the FPGA, and they get read from the Python socket, and you can write bytes on the FPGA, they appear from the other end, and you can implement pretty much any algorithm you want with cycle accuracy. You can do things like glitching. The shortest glitch that this board can reliably generate is about 3 nanoseconds, and you can do this with about 10 nanosecond resolution. So that's a part of why it's interesting. But the other reason why it's interesting is all the things that I've built, because if you are setting out to build something that is fun to use, that feels like the language is working with you and not against you, something that doesn't have sharp edges that scare off novices for very good reason, they're entirely right to be scared, and constantly bother professionals alike. If you want to build tools that are really made for people to comfortably use, you have to start from fundamentals. So one of the components that I have built, again, it's a collaborative project. I started by basing it on a different programming language called Mygen. It's a language called Amaranth, and it's a Python-based hardware description language and tool chain, and it also has a simulator. So you have pretty much everything that you would need to start making code. And is it available in the browser? I'm glad you asked. Yes, it is available in the browser. So this is some example code for an ultrasonic sensor, I think, on the Glasgow. Let's see if it works. It does work. So right away, you get some test data, and you can look at the waveforms, all without ever having to install any toolchain components or even install Python. This doesn't work, of course, for more complex software, but I think this is very useful for beginners, or if you just want to share a small snippet of code to explain something to somebody. To make all of this work, I had to build the FPGA toolchain to WebAssembly. And I'm actually using this even for native command line installations because it's much easier than cross-compiling the tool chain for like 15 different platforms poorly. It's on NPM and PyPI. And usually I would ship all of these things on GitHub pages. However, GitHub has recently decided to go all in on AI, and their service is kind of falling apart. And they've been doing some politically concerning things. So I ended up building a service that is a replacement for GitHub pages. It's called GripDoc. And it's actually faster than GitHub pages. We also use Anycast routing, and you can start using it pretty much exactly like you were using GitHub pages. There's software behind this site. It's open source, and a number of people have been using it. Codeberg have been deploying it. So all of these things that I have started working on for or in relation to Glasgow and Amaranth, they have been benefiting other people. Like, for example, there's another open hardware project that I'm not sure if you've had this project on before. If not, you really should. It's a modular synthesizer, also based on FPGA. It's programmed in Amaranth, and it's an absolutely lovely device. It's going to be my introduction to synthesizers. Yeah, I think that's a good introduction of what I'm doing and why.
Yeah, no, that's amazing. This is such a really, like, this project is so cool and like really helps capture like this really specific area of like just wanting to be able to mess around.
Yeah, I think that play and generally undirected exploration is incredibly important for you to actually understand what's going on. And this could be important for debugging your system, but this could be equally, if not more important, for learning electronics, learning digital design, understanding how all of the little chips on your PCB interact together. One of the things that Glasgow offers is that you can connect it to a UART, and it will sniff the communication, and it will tell you, like, let's say you connect it to a GPS module. So it will tell you both sides of the communication, the request and the replies, but not like a logic analyzer where you have to do a separate decode step. It will just give it to you directly as text. And then using 2 lines of Python code, you can write a decoder for this, or start writing a decoder for this, which takes the GPS messages and turns this into coordinates. Or it has a similar facility for SPI and Quad SPI, and they have a snippet somewhere. It's like 50 lines of code that decodes SD card communication to a file system image that you can just mount. And because Glasgow is a library first and the command line tool second, you can take all of the pieces. Let me just show you how to do it. An example of the code that we have. So this is an example of how to use the applets without CLI. Pretty much what you're doing is you say what sorts of interface are you going to use, and then you start up the device, you configure them, and now you can interact with a tool that you have just constructed yourself in several lines of code. There are no tricks here. I'm not hiding anything. This 60-line file, including documentation, which is 20 lines of it, is a completely new tool that is application specific, that is made for programming a particular microcontroller's SPI interface while keeping it in reset. You could imagine this being used on a manufacturing test line. So this code is drilled down to its essence. You're not being bothered by things that are not relevant to your goal as engineer who wants to apply a tool to a device under test and who doesn't want to spend hours debugging why the tool you need to debug something else doesn't work. And this is another principle that I have been using throughout this stack. The tool must be reliable. It cannot fail under you, because there's nothing more frustrating than wondering whether it's your device is wrong or your debugger who is wrong. There's multiple levels of reliability, including hardware reliability. So for example, we have a button. There's one button on the case. And what is it for? Well, it resets the entire device completely. Why is it there? Well, it's usually pretty bad for electronics to be connected while it's powered on, or while you have a strong driver on some lines. So to make sure that this doesn't happen to you and end up frying some expensive piece of equipment you're going to need to wait 4 weeks to replace, we are training every end user to click the reset button, which is guaranteed because it's fully hardware. There is only virus there. It's guaranteed to reset the entire device and turn off all power supplies and turn off all voltage outputs. That is one aspect of reliability where it is made to be safe by design, and it's also used elsewhere through the stack. But this is, I think, is a good example.
Yeah, that's a pretty great example. Also, really appreciate the drop that you just decided to spin up a alternative to Git pages. That's really cool.
Yeah, I've been putting quite a bit of effort into this project. It originally started as a replacement for Codeberg pages. So even though I make so many tools that are quote unquote my tools, they're usually collaborative works, I don't I don't do it to do something of my own. I prefer to collaborate with others, and I tend to build things only if there just isn't anything available here. And Git pages was started as a project built for Codeberg to deploy on their infrastructure, which did eventually happen. It takes a bit of time for an organization staffed by volunteers to do the full cycle, but it is in progress. And the deployment on GripDoc is something that I've done to gain operational experience, so that I'm not offering untested software. So now you have an alternative to GitHub Pages. It's very cheap for me to run. I pay 35 euro per month for the entire thing, including Anycast routing, which gets you less than 100 millisecond latency in most of the population centers, except for Africa for now. So people can just use this. There is an university professor who publishes a book and lecture notes, and his repositories are about something like 1 gigabyte in size. And I just publish that because I can publish that, and it's not really a problem. I do compression, transparent compression. So if your browser supports compression, then it's going to be sent a compressed file directly without decompressing and then recompressing it again, which saves a lot of energy. And I do deduplication so that if you're uploading a file that's already been seen, it doesn't appear again, or if you have two identical files that are coalesced, which can reduce the size of a page, of a site that's being pushed by often over 50 or 70%, which really makes this not a particularly burdensome thing to run. So that's why I feel comfortable saying, yeah, you can use it instead of GitHub pages. It's fine.
Yeah. That's awesome. This has all been really cool. This is such a great series of projects to be working on, and like, I also really love the fact that you are so clear about like one of the really beautiful things about open source is working with a team and getting to work with other people, and so it's really rad that you're so open about that. That like these projects don't happen on their own; they never do.
Yeah.
Thank you so much for coming on today and telling us about the Glasgow Interface Explorer and also your side projects.
Yeah, thank you. I was quite happy to tell everybody about them, and hopefully, some people would be able to migrate their infrastructure to something that is less questionable.
Yes, I think we would all like that these days.
Yep.
Amazing. We'll talk to you soon, Catherine.
Talk to you soon.
Bye.
See you. Bye.
Okay, so you might have noticed that that was technically 2, but a little bit secretly 3, thanks to Catherine, projects for this month. We had a slight issue with timing with one of our other guests, so we will have to have them on another stream, but thank you so much for coming out today and getting to see what folks have been working on in the community and get to participate and know what's going on. It's always really fun to run these live streams and just like really get to see how folks are engaging with open source right now, and I'm really excited to see what we get to talk about again next month, because we will be back again next month with more projects, more stuff to talk about. And for now, though, that is the end. This will all be available on YouTube forever and ever until YouTube explodes. So thank you so much for joining us for another edition of Show and Tell Monthly, and we'll see you next month.